Monday through Friday, 8 to 5, every single day for 15 weeks, 4 months. And in that program, they will get over 600 hours on state-of-the-art, high-tech equipment. And their goal is to obtain work and employment in high-tech companies. And we usually have small-sized classrooms, maybe 8 to 10 students at a time, which is perfect for hands-on. We try to balance the theory and the hands-on lab activities. So it turns out to be an amazing environment. And some of the parts of the curriculum, and I guess I could walk through here and you could see some things. This goes, okay, perfect. And I'll try to back over as the 3D printer. I think it just finished one of the objects. Some of the things that the students will go through are electronics theory, soldering, surface mount through hole, hydraulics, pneumatics, automation, robotics. What else? What are we studying? PLC, mechanics, fabrication, and you just name it, lean manufacturing, QC, QA, SOPs, maritime, underwater ROVs, just about everything we can cram into 15 weeks full time. A lot of this stuff, and I was a dormant amateur radio operator for so many years, but I realized what we're teaching is there's so much overlap with amateur radio. These students, and I get students right out of high school that don't know what they want to do yet in life, and maybe a 4-year college is maybe not, they're not ready for that. Or I'll get people right out of the armed services looking for a career, or I'll get people changing careers. So it's an interesting group to work with. But amateur radio has so much overlap in this engineering area. I thought, well, can we blend some of that into the curriculum? And so I did a couple of things. I looked at the technician license and what it takes nowadays to get a technician license, and it's favorable to what can be accomplished. And I reached out to the Palomar Amateur Club here, and Charlie and Glenn have been amazing. They showed up like the next day. Well, maybe not like the next day, but they showed up and worked great with our students. And I was looking for basically something to spice up what we do and bring the electronics, all this stuff together. And amateur radio was the hot sauce. You know, it was the ingredient that really we found that it made it really interesting with the classwork in the coursework. Let me see what I see here. State of technologies. Miracosta has a main campus in Oceanside, but we have been fortunate to just open a year ago our high-tech facility right here in Carlsbad. It's probably 3 miles away, right on the other side of the airport, where we have our program, which is the 4-month program. We have a 12-week machinist program where students come in and they will learn machining on manual equipment all the way up to CNC equipment. And I love that stuff, so I'm like drooling every time I see them building stuff. But we have our own stuff in our own laboratories, and we're working on, we get to work on robotics, automation, 3D printers, and I'll get to that in just a little bit. So last fall, we talked to Charlie and Glenn, and they came in and got our students excited, and I folded it into the curriculum. We would go through 9 chapters. If you've seen the newer stuff, the newer curriculum, it's 9 chapters in the book for the technician license. We would attack like 1 chapter a week in the class and go through it and prepare them for that, and they did great. And we were fortunate that the club arranged for volunteer examiners to come in to our facility and administer the test to our students. And that was a blast to see that happening and see that. And the outcome, we had new amateur radio operators. And this was just in the month of, I think it was December, right at the beginning of December. We had 6 new amateur radio operators. I currently have a class right now of students, and due to time constraints, I'm not like requiring it mandatory, but if you are interested, and half the class are starting to study the book to become amateur radio operators. Now, I also like to get them excited about it, and so we have a 2-meter radio. They built a 2-meter vertical. We put it on the roof. We built a dipole. So let me start talking about a little bit of technology. 3D printer that you see here coming in as you come in the classroom, if you get to see that. I noticed like in the QST magazines, these are like some of the latest QST magazines. One has Arduinos in there, projects on Arduinos, and the other one, right on the cover, there's 3D printing. And so what we're doing, what we're talking about is being folded into amateur radio operators. This is what I love about it. It's about experimentation. It's about testing the limits and what can you do with this equipment. Some of our students were challenged to build things, and one way that I know Charlie wanted me to talk about the integration of this, and one of the things that we just built, and I'm going to pull it off right now, and this is something a student designed in SolidWorks, and then he printed it out, and it's a dipole mount, so he puts the SO239 right in here and mounts this to the pole, goes off to the guy wires, and then he has some nice little mounts that will hold off the outer sides of the antenna. It's perfect, and he designed it right there. Another example of the technology that we teach SolidWorks is one of the CAD/CAM modeling tools. And this is something I wanted to show our students, kind of get them excited about something that had to do with amateur radio, and it's a Morse code little trainer. But this is 3D printed. I had spare parts. I had some batteries, a noisemaker, a switch, LED, and in 20 minutes, I had this modeled in SolidWorks. 15 minutes later, it came right off the 3D printer, and probably 10 minutes later to assemble it. And now we have something that didn't exist, and now we have something thanks to the technology of like a 3D printer. Now I know people talk about it in the news and they go, oh, a 3D printer that prints food. Not quite there. I guess you could say it's there, or I just heard tonight about a 3D printer that can build a house, a big one, so that's interesting. But to me, it's technology. It's technology that, as a TV is in most of our homes, as common as a TV, the 3D printers are going to be in maybe 5 to 10 years as common as a TV. And if you can imagine, if you need something, and I don't know, I can't have something, I don't have anything off the top of my head practical, but if you needed something, you could just download it, print it, and you have it. I think sometimes, like, I have a 3D printer at home, and sometimes they can take 8 hours to print. But I'll set it up at nighttime, and I'll start it printing, and when I wake up, it's like Christmas. Like, there it is, it's like printed, I'm like, oh, awesome. And so the technology is there, and it's becoming more and more available. And I mean, in the whole like vein of amateur radio experimentation, that's a tool that you're seeing in the news. I hope by showing you an example of one. We have several in our classroom. We have one that was around $300 from China that our students put together without instructions. There weren't good instructions, so it's a great challenge for our students. Actually, there was a video, a silent video on how to put it together. We didn't get it right the first time, or the second time. About the third time we got it working, and we got some parts. Then our director said, Kris, what can we bring out to the community to show people what we're doing here with our technology program? We have a huge robot. You'll see a picture of it in a little bit. It's a Rethink robot. It's one of the latest types of robotics that instead of a keyboard, a computer to program it, you grab its arms and you program it to do various objects, and you stand back and it will do it. And it can be safe to be around a human, because most robots in an industrial manufacturing environment, you cannot be near them because they'll move over, take off your head, and keep going. Right? But these are the new style. But they're still big. And my director is like, she's like, what else can we have to show off what we're doing? And I said, well, we need another 3D printer. So we went and got the Dremel 3D printer because it's about $1,000 and it works pretty much most of the time. So, and that's a good thing. But our one that we have to put together is, I love it for the engineers and the engineering technicians because it breaks all the time and they have to figure out how to fix it. It's like, I couldn't have designed anything better than that thing. It's because the companies that we partner with and we talk to, I always say, what's the top 3 things that you want out of our technicians? And always on the top 3 is, can they troubleshoot? And I'm always trying to design labs where they have to troubleshoot and figure things out, but none of them have come close to that $300 3D printer because it's always breaking and it's something different they have to troubleshoot. So it's perfect. I won't tell you the brand, so I'm not.
MFCA.
But I must say that I bought that same 3D printer for myself at home, and with a little tender care and love, it's amazing. It works great, better than this $1,000 one. So, and when mine breaks, I go to school. Let me see if I can get something else going here. I'm going to talk about some of the other fascinating parts about this course, and I won't take all your time. You might have saw a little circuit board as you come in. It's an Arduino. I think more and more people are becoming familiar with what it is, but it's a microprocessor. It's something that's becoming more and more easy to program, especially for the layperson that might not understand it. You can get code, and for less than $20, you can actually start to do some pretty amazing things with some circuitry. Kind of reminds us, if we go back to the earlier stages of amateur radio, right? Where you could put things together, take them apart, and it's not like the cars nowadays where there's no way you're going to work on it, right? Because you need to plug it into a computer and stuff like that. But it goes back to those days. That's what this Arduino is. When you start to see references to that, and on this one is a simple gesture sensor. So it's using infrared and it's monitoring where your hand is going, and then we just program it to do lights or the annoying buzzer right there. I was trying to make like a here, where it's like a hands-free here, where you're just going like this and doing Morse code, but it got too annoying, so I didn't unplugged it, but I think someone plugged it back in. As you can see, what we have here too is some of the projects we've worked on. Some of it goes away from amateur radio, but it still has ties into experimentation, design, electronics. They will work with and create an underwater ROV. In the news, you hear all about drones. Everything's about drones. Really, the untapped area that's just, it's almost going to be as popular as drones is the underwater robots. Because there's so much unexplored, so many opportunities in our waters. And part of our project to understand the engineering that goes behind it is working with underwater ROVs. Most of our students say, I want to make one that's remote controlled. Now this is where it ties into amateur radio. Radio waves underwater is not easy. It's almost impossible. So you eliminate the remote control aspect and how you communicate underwater. So that when they hear, oh, you have a tether or a line going down to it, they think, that's like caveman style, right? I'm like, no, it's not. If it breaks, you just pull it back, right? But we work with the companies like robotics, which has state-of-the-art, amazing ones. They have tether, but their technology isn't their tether to make that work. But then our students understand the limitations and the engineering behind how do you communicate with something like that underwater, and how does the radio frequency work under there. So it's just, again, goes back to the experimental part of amateur radio and why many of us gravitate towards this. Go ahead and here we have Charlie. He came in, and our students built a 2-meter vertical antenna. We put it on the roof. We had no idea. We didn't have an SWR meter or anything. I didn't know if it worked or not, but Charlie brought in some equipment, and we tested it out. take all the credit. No, our students did great, and it was just another fun hands-on activity that's just going on in your community, this community right here. Let's see if I can. How do we integrate ham radio, amateur radio, through the theory, the skills? We talked about the propagation, the different styles, communication. Many of our students don't realize in the world of engineering how much of it is documentation. They think, oh, I'm going to make the best, the latest robot, and I'm going to make this and that, and go fly to Mars, and there's documentation behind everything, and it's kind of a shock. But then when we studied the guide to become a technician, about the procedures, the protocol, the propagation, and everything, they go, oh, that stuff is important. I understand how that works and how that comes in. So just another way to tie that in with our projects and experimentation. And we're still looking for ways. We do have a couple of older 2-meter radios in the lab, but at some point I'm looking for an HF radio so they can actually hear some really distant stations and contacts. And so someday we're going to outfit our lab with a HF radio. Let's see, again, how do we integrate? What are we doing here? With our design cycle, that I want our students to walk away with is, if they have an idea, they can learn and take that idea and make it tangible through SolidWorks, or an online tool, or a computer tool to model something like this, then to be able to quickly get it printed out. Where before 3D printers, you'd have to often have a machine shop make this, and it would take a while and come back. But now a 3D printer, they can get something back very quickly. They can test it. They can see if they like it, if it works. They can then refine it. They can share it with their friends. It's just it's part of a new style of engineering and designing, and it's made practical and fun, and it's not so far out there that you can't comprehend it. I think for those in this room, if I gave you 2 minutes each and showed you how to do this stuff, you could be designing crazy stuff too, and having fun with it. We'd never leave, but we'd have fun with that. This is an example of the Rethink robot that we have. We have a couple of these robots, and they're very easy to program. I wish I could bring one in and show it off. They're just amazing pieces of technology. How I link it to ham radio, I don't know, other than radio control or the challenges. My last group of students, I challenged them to do a problem that only the robot could really do. And I look over 15 minutes later, and they had programmed it to, on a golf course, you putt the ball. They had programmed it to putt the ball into a hole. So I'm like, that's the generation, that's the next generation. They're hungry to learn, to experiment. And I think this is an untapped area with amateur radio. It's just not available in the news enough that they know about it. Does that make sense? So I don't know how yet, other than to, every new group of students I get is to share more and more about it and the opportunities. I do have a short video just so you can see the classroom a little bit. And it kind of highlights the underwater ROVs that they put together. And it's on YouTube. If you can click over to the YouTube and see that. Oh yeah, no worries. We got around it by going to YouTube. Oh, and they're not working. Right. As it's loading and coming up too, our facility, which is just 3 miles away, is open for tours every Friday. You can just show up. There's information flyers here. If you show up, man, I'd love to show you around the labs and answer any questions that you have. We also have an open house that's coming up March 5th. I think it's on the flyers as well. If you'd like more information, We also offer evening classes for like SolidWorks, electronics, soldering. We partner up with many of the local companies. Our last class of students that just graduated, they're all now employed here in high-tech companies. I mean, we're thankful to Viasat grabs them, TE Connectivity grabs them, engineering companies grab them because they realize that it's sometimes it's a dying career, that not enough, the younger generation are not in there as much anymore. And there's so much opportunity. So if you're working for a company or you're part of a company and you need technicians, stop by our facility sometime, and at least let me show you around and let me show you what they're learning. If it doesn't work, that's right. Well, I can just point. There's one of our underwater ROVs, and we have a really cool lab. I have a couple of interns from UCSD. They're electrical engineer seniors, and they come into our lab, and they honestly, they're like, Kris, this is better than our lab at UCSD. And I know a few of you in here in this room have seen our facility, and you probably agree with me. We are very fortunate. We have state-of-the-art, high-tech equipment. We are so fortunate to have that, and most people don't know that, right? So maybe I had a better video, but we have tours. Yeah, we do have tours every Friday. There's information here if you'd like to stop by. Please, I recommend it just so you can see what's going on, and we don't worry about that. Maybe the webmaster. Maybe your webmaster will let me put a link up on your website, so later on, if someone wants to go, they can click on this or something. So
this is being live cast on YouTube right now. I'll put a link. Send me the link. Send the link to the board.
Oh, okay.
I'll make sure it makes it into the YouTube announcement. Okay. Somewhere right here.
Okay, you got no problem. So check that. You can see that, or better yet, come in person. Stop by on Fridays for a tour. Love to show you there. Hear about it.
Okay, there we go.
Oh, okay. It's just a music in the background. Any questions? Grateful to be here. Any questions about anything we're doing or what's going on? Yes.
Just remind everybody that after Friday night, there's a class several times. I wrote an article with the scope, so go back, I think, 2 months, get that, links in there. So I think it's that video. And,
Is that like November or December scope, probably?
I think so.
Okay.
Also, if you're at a company or you have resources that you don't need anymore, especially electronics, any expendable things, we can always use them. We've been fortunate, some of the engineering companies, they move their stock out and get new stock, so we get resistors, capacitors, components, circuit boards, and we love that. The more the better, so we always are open to using that. And it goes to great use in preparing our next generation. Not only the next generation, but people that are wanting to change careers and getting into, to me, an exciting career.
Yeah, well, Johnny, an excellent presentation, and wanted to know what the prerequisites for a student to get into this program.
Great question. The prereq to get into this. They will go through written test and a math test, but it's at a high school level. So our prereq is you graduated high school and you can read and write and do some math. The rest, because the program is geared a balance between theory and hands-on, we have had no problem with all ages, all skill levels and skill sets, and bringing through successfully the program. We also pair up with a work skills navigator that work on resumes. We have leadership development. We bring in consultants we surround our students with the skills to be successful. So thank you for bringing that up and reminding me that this is a comprehensive program.
What's the cost?
Great question. Oh, okay, here's where it really gets to come. Even though it is near Costa College, and it's this is a self-sustaining program, so the cost is, I think it's $5,500 for the 4 months. Now, the way I view it, for the students that come through here, some of them get funded by the state, some of them have military funding, and some out of pocket. To invest $5,500 in a 600-hour program to start a career in the high-tech field in 2 years, if you're even making at the lower range before you work your way up, that $5,000 is nothing compared to a new field. And some of the past students have come in from being chefs or in completely different fields and now working in high-tech companies. So there is a cost. But for those that are hungry to survive, and not hungry to survive, but motivated to really are passionate about this, it's a stepping stone, and we work with that. We work with them too. So thank you for that question. Yes.
Yeah, are you doing anything with audio or ESP?
We don't. Audio in our labs where we analyze signals, but we don't specifically get that.
Okay, more radio.
Mm-hmm. Yep. Yes.
Just out of interest on the tethering of the motor vehicle, what kind of communication?
For our projects and our kits, it's simply electricity to fire the motors, to get the motors going, and some Arduino controls to control some of the things. If we get fancy and have a gripper, either running a pneumatic gripper. For the commercial type, they're running, it's 2 ways. Oftentimes on board on the ROVs is the CPU or the brains. So it's more just control pulsing going down the line to control that, but the brains are on board. To answer your question, I think we could. Oh, it's copper. Although, I'm not sure if I can say it. So robotics is also working on fiber, and some of those other places are working on fiber too. This is interesting for our students to realize. When they tether theirs, we often have big cables because some of them get aggressive and they want many motors on there. But when we go to robotics or a commercial brand, it's very small and light and strong because of the technology they have and they're using. It's a world of difference. And oftentimes, you know the tail that wags the dog? Some of our projects from our students have been like that. It kind of, the whole cabling is kind of overpowering all the motors, whereas the more commercial ones, since they're putting thousands of volts down into theirs, it's different. But we can talk more about that. It's fun stuff to talk about. Any other questions about the program? It's never too old to change and go into engineering technician, machinist technology, or if you just like to see that and witness it, you can come to a tour or come on over to see the facility. Yeah. Yes, the formal tours every Friday, starting at 9 a.m. You just show up. We are a state-of-the-art high-tech facility in an industrial park. Right across the street from us is Spy Sunglasses. We're right there, and you can come on up and say, hey, I'd like to see the tour. And we have people giving the tour, and you'll definitely see me and come on and say hi, and I'll show you the labs. Starting at 9 a.m. And I think they'll go till 1. You can come on in anytime. Just say, hey, I'm here for the tour. Love to see you. Stop by. Address, I have it right on the flyers right up here. It's, yeah, probably just best if you grab a flyer and see that. It's on Las Palmas Avenue. 2075 Los Palmas Avenue. On your way out, grab a flyer to see that. I love the aspect of working with other companies in the area. There's a company called Automation GT. They have customers that want custom solutions on automation equipment. For some reason, they don't have I'm sorry if anyone works there. They don't have a 3D printer, but they call us up and say, can you quickly print this for us so we can test it out? I'm like, okay. So I give it to the student. The student takes it, prints it out, sees the print, does everything, and then runs it over to them. Because now the student gets a chance to work with their engineers to see how that works and how that integrates with the system. I'm like, this is awesome. Don't get a 3D printer. Use us, because that gives our students more time with their engineers and with their system, and they get to see that. And I think that's part of what the program is all about and what makes it successful for what we're doing. In the future, in 2016, what am I looking for? I'm looking for my students that we get in the next groups to come through to get excited about amateur radio, to get more people out there experimenting, to understand that, to become part of that. And I'm looking for ways to get them excited and motivated about amateur radio, like I was. When I was young, before high school, the only way I knew about it is I went up in the attic of my great-grandma's house, and there was an old tube-looking thing, and I asked my dad, he's like, plug it in. I plugged it in, there's this dial on it, and the tubes were glowing, and it was like, you don't see this stuff, and it was awesome. And I remember WWV from Colorado, there was a frequency, this is back when I was there, was a frequency, I put it on, you hear like a click, 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 click. I mean, I don't know if anyone knows that here. It's still there, and I click, click, and I was like, what is this? And my dad was trying to explain, that's, 1,000 miles away, and here's this little wire, and I'm like, how is that possible? This is crazy. And then that just got me excited, and I just had to know more and more and how this worked. And still my favorite times when I was younger as a teenager, a little Morse code set in my bedroom, probably like 10 watts, and I'm communicating like real time with someone on the East Coast. It just blows my mind. Like, that's crazy. And I think sometimes we lose that with like technology today, with the cell phones and the internet. It's not as mind-blowing, but I think we need more of that. And that's what I'm here hopefully to inspire this next generation of students coming through there. So,
would you say that it was a benefit to you that the class at the time that the hands that time?
No, they hated it. No, I'm kidding. I'm kidding. They loved it. I think it was a great benefit because, for one, it opened up more people that have been influenced and have that experience. So they